In this video, we're going to discuss the empirical rule. So if data has a distribution that is bell-shaped, then the empirical rule can be used to determine the percentage of data that will lie within k standard deviations of the mean. So if a distribution is roughly bell-shaped, then approximately 68% of the data will lie within 1 standard deviation of the mean. That is, approximately 68% of the data lie within the mean minus a standard deviation and the mean plus a standard deviation. Approximately 95% of the data will lie within 2 standard deviations of the mean. Approximately 99 7/10 of the data will lie within 3 standard deviations of the mean. So we can also use the empirical rule based on sample data with the sample mean and the sample standard deviation. So I could write this as this. And with 2 standard deviations, I could do this also. Okay, so 68%, 1 standard deviation. Well, how are they getting 34? That's 68 divided by 2. That's 34%. Well, how are they getting the 13 5/10? Well, that's the 95 minus 68. That's 27. And then 27 divided by 2 is 13.5. And you can do similar things to figure out what the other percentages are also. Okay, let's take a look at an example. So the Stanford-Binet Intelligence Quotient, IQ, measures intelligence. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. Fill out the bell-shaped curve with the appropriate numbers on them. So first of all, there's a title, IQ scores. So on your paper, you can draw a line segment with some slashes going up and down, and then draw your curve. So keep in mind, the mean is 100, and the standard deviation is 15. So we know the mean is going to go in the middle. Now, with the standard deviation and going to the right of the mean, I'm going to add the standard deviation. So 100 plus 15 is 115. 115 plus 15 is 130. And 130 plus 15 is 145. To go from the mean to the left, I'm going to take the mean minus the standard deviation. So 100 minus 15 is 85. 85 minus 15 is 70, and 70 minus 15 is 55. So now that we have the bell-shaped curve with the appropriate numbers, let's answer some other questions. So what percentage of people have an IQ score between 70 and 130? So here's 70, here's 130. That is 2 standard deviations on both sides of the mean, so we know that's going to be 95% of the data. What percentage of people have an IQ score less than 85? So it's this region, and this region. So the 3 numbers would be 13 and 5/10 plus 2 and 3500 plus 0.15, and that would be 16%. Or you could take 1 minus. Well, we know from 100 to the other side is going to be 50%. And we also know from 100 to 85 is 34%. That would be 100% minus 84% is equal to 16%. So notice I changed the 1 to 100%. Okay, part D. What percentage of people have an IQ score less than 70 or greater than 145? So now we'll get rid of this region. It's those 2 there, which we know is going to be 2.35 plus 0.15, and greater than 145 is also 0.15. That's going to end up being 2 and 6500%. Okay, let's take a look at the next example then. So the following data represents the serum HDL cholesterol of the 54 patients of a family doctor. Now, you would need to know the population mean and the standard deviation. So that's been done for us. The population mean is 57 and 4/10. and the standard deviation is 11 7/10. Part B shows that the histogram is approximately bell-shaped. So that means we can use the empirical rule for this. So part C, we want to fill out the bell-shaped curve with the appropriate numbers. So let me draw that now. Okay, so I've got a title, Serum HDL Cholesterol, and we have the bell-shaped curve. Now, again, in the middle, it's going to be the mean, which is 57 4/10. So again, if I want to go from the right-hand side of the mean, I'm going to take the mean and add the standard deviation. So 57 4/10 plus 11 7/10, that's 69 1/10. 69 1/10 plus 11 7/10, that's 80 8/10. And 80 8/10 plus 11 7/10 is 92 5/10. Going from the left side of the mean, I will now subtract the standard deviation from the mean, and I get 45 7/10, 34, and 22 3/10. So there's our bell curve with the appropriate numbers. Okay, Part D. Using Part C, determine the percentage of all patients that have serum HDL between 34 and 69 1/10. So that's going to be this particular region. Okay. Now, we know here and here is 34 plus 34. That's 68%, but I'll break it down. And then the last particular region here, that's going to be 13 5/10%. So when I add up all the percentages, it's 81 5/10%. Again, using the empirical rule. Now note, the actual percentage of all patients that have serum HDL between 34 and 69 1/10 is 45 out of 54, which of course we can simplify to 5/6, which is 83 1/3%. So again, when we do the empirical rule, it's approximately a particular percentage. It's not the actual percentage. If you wanted the actual percentage, you would count the data values accordingly. But notice, the answers are pretty close to each other.